IQs follow a bell-shaped curve with a mean of 108 and a standard deviation of 6, and we want to use this to answer the following questions. So there's 4 questions here, right? To find a percentage of people with an IQ greater than 114. We want to find a percentage of people with an IQ between 96 and 102. We want to find the z-score of someone who has an IQ of 120, and then if someone has a z-score of negative 1.2, what is this person's IQ? All right, so a lot of questions here, but let's go through each of these one by one. Okay, so what does it mean by a bell-shaped curve, right? So let's just draw this on the right side here. So let's say we have this bell-shaped curve. We'll learn more about this distribution later, right? But it says that if it is bell-shaped, okay, and the mean is 108 and the standard deviation of 6. Okay. So what we want to do here is, the middle or the mean here is going to be that 108. Okay, so this sort of has to do with the empirical rule. Okay, we know that if the data is within 1 standard deviation of the mean, that encompasses 68% of all of the population, essentially. Okay, let's think about what that means, right? Okay, the standard deviation of 6, right? So if we go 1 standard deviation to the right, so if we add 6 to this, okay, we'll get 114. And if we subtract 6, we'll get 102. Okay? Remember, that's 1 standard deviation, right? So 1 standard deviation above the mean and 1 standard deviation below the mean. But what does this mean? It means that 68, right? 68% of the population has an IQ between 102 and 114. Okay? And because this is symmetric, okay, well, if this is the middle 68%, then each half here should be 34%. Okay? So those are the conclusions we can make from the empirical rule. We also know that if you go 2 standard deviations away from the mean, okay, that encompasses the middle 95%. Okay, so let's go 1 more standard deviation. So we'll subtract another 6. We get 96 here, right? And then if we add another 6 to this side, we get 120. Okay? So once again, what can we conclude? We can conclude that between 102 and 114, right, that's going to be approximately 68% of the population. Okay? And similarly, between 96 and 120, right, that will be approximately 95%. Now, it's not exact, right, but it's pretty close. Okay? And once again, because this is symmetric, right, we can sort of, I'm not going to say play around with the numbers, okay, but we can sort of get these percentages of these certain sections as well, right? Okay, so let's see, what percent of people have an IQ greater than 114? Okay, well, let's think about this, right? Okay, this is the middle 68%. So this has to be 34% here. Right? This has to be 34%. This has to be 34%. Okay? But let's think about this. This is the midway point, right? This is the mean. It's also the median. So this is the 50% mark, right? So 50% of the people have an IQ below 108. 50% have an IQ above 108. So this is 50% from here to here, plus this 34%. So 84% have an IQ below 114. Okay. So if 84% have an IQ below 114, what percent then have an IQ greater than 114? Okay, well, 100 minus 84, right? So 100 minus 84, so that'll be approximately 16%. Okay, so approximately 16% of the population has an IQ greater than 114. What percent of the people have an IQ between 96 and 102? Okay. So here's where we've got to look at the numbers here, right? So we know that 2 standard deviations away means 95% of the population has an IQ between 96 and 120. Okay, well, okay. So that's 9. This is the middle 95%. So what is half of 95, right? It's going to be 47.5%, right? So this middle part here, or not the middle part, right? But this left part here should be 47.5%. And of course, from here to here should be that other half, right? That other 47.5%. Okay. But we want the percentage of people with an IQ between 96 and 102. So we actually, for part B, right? We actually want just this portion right here, right? Between 96 and 102. Well, let's look at the numbers, right? 47.5% of the population has an IQ between 96 and 108. 34% has an IQ between 102 and 108. So you see, okay, I just have to actually subtract these two together, right? So the answer to part B then should be, right, 47.5% minus 34% here, right? That gives us 13.5%. Remember, this is using the empirical rule, okay? So we can actually get these exact values a little bit later on when we start going with the normal distribution. All right, so what about part C? We want to find the z-score of someone with an IQ of 120. Okay, so remember the z-score represents how many standard deviations away someone is from the mean. Okay, so it turns out in this case, well, wait a minute, I know that this is exactly, in this case, right, 2 standard deviations away. Right, there's actually a formula for this, right? The z value will be, okay, the data in question minus the mean divided by the standard deviation. Yeah, definitely you want to memorize this guy, right? So the z-score is going to be the data value in question minus the mean divided by the standard deviation. Well, let's check it out. What do we have in this case, right? Someone with a z-score of 120. So in this case, x is 120, right? So we're going to take the 120 minus 108, divide that by 6. So we get 12 over 6, which is exactly 2, which makes sense, right? So a person with a z-score, a person with an IQ of 120 has a z-score of 2. So this person is 2 standard deviations above the mean. And the last question here, right? Okay, I know that this person has a z-score of negative 1.2, but what we want to do is we want to find this person's IQ. Let's think about this carefully, right? We know that this z-score here should be negative 1. Okay. This z-score here should be negative 1, okay, because we are 1 standard deviation below the mean. So we know that this z-score here, right, if a person has an IQ of 96, their z-score should be negative 2. So, you know, the answer to this question should be something between 96 and 102, but maybe a little bit closer to 102, right? Okay. Well, of course, we can always just use this formula to get the answer, right? So we know that the z-score at negative 1.2. We want to find the data value where that z-score lies. We also know the mean, which is 108. And the standard deviation in this case is 6. So just in here, we got to just use a little bit of algebra, right? So we can use a little bit of algebra just to find this answer, right? So we'll multiply both sides by 6 here. So we get negative 7.2 equals x minus 108. And of course, from here, we'll just add that 108 to both sides. And that is going to give us our final answer here. Okay, 100.8. We can leave it like that, or we can round it to the nearest whole number. We're dealing with IQs here, right? So hopefully that makes sense, right? Negative 1.2 should be about over here, right? So if this person has a z-score of negative 1.2, then this person's IQ is approximately 100.8, or if you round that to the nearest whole number, we can call that 101. Make sure you memorize this formula here, right? This gives you the relationship between the mean, standard deviation, the data value in question, and the z-score.